Hello. I'm going to talk today about a common misconception and how it relates to the concept of the math calculus derivative and differential. But you do not really need calculus to understand the first part of the video. What I'm going to talk about, well, let's get right to it. Um, right here, I was going through social media and I am deleting the name of the person who posted this because it's not my intention to pick on a human being or pick on an individual, but I do want to point out a um, a misconception that I've seen in K through 12 textbooks. And this right here, they're talking about a volcano that exploded, was very loud. Um, I cannot vouch for the correctness of the first part of this. What I wish to focus on is this thing right here. It said this cooled the entire Earth by an average of 5 degrees centigrade. And, but then look what it goes on to say, 33 degrees Fahrenheit. Now, does that make any sense at all? I mean, if you think about it, let's say it's 20 degrees centigrade, and that's kind of a chilly temperature, but um, nothing special. And then it cools to 19.5 degrees. Well, does that correspond to a 33-degree drop in temperature in Fahrenheit? Of course not. And you see right here, this is a fundamental error in thinking right here. This right here. And I'll just state it, a 0.5 degree Celsius drop in temperature does not correspond to a 33-degree Fahrenheit drop. Now, the very first question is like, well, where did the author get this? And it's actually quite easy to see. And what I'm going to do here is just go and let's go to something Celsius to Fahrenheit conversion. So if you do that, and well, let's just do that. I don't know why I did that, but let's go back to the other one. I think this AI stuff just is awful. So let's see here. Well, I guess it's going to be, well, I'm trying to make this easy, but this was a lot easier before all the wonderful AI. Yeah, I'll just go ahead and do it with the formula here. So if you put on the formula there, and the standard formula, which I know, is the degree. If you have a degree Celsius, what that's going to equal is 5/9 times the temperature Fahrenheit minus 32. Or if you wish to solve, in other words, you want to put here and solve for that, that's 9/5 Celsius is equal to Fahrenheit minus 32. And you get this. And evidently what the author of this meme did is if you just take 9/5 multiply it by half, plus 32. Yeah, well, what do you get? Well, you get 9/10. You get 32.9. And he rounded up to 33, and that's how we got 0.5 to 33. Now we know that's absurd. Now this is wrong. I mean, this thing right here is correct, but the the calculation and the meme is wrong. In fact, is downright absurd because we're not talking about a half a degree Celsius just above freezing day temperature translating to that, which it does. We're talking about a change. So if we do this in algebra, and let's just start off with this formula here. So if you have formula 1, you have Celsius 1. And we're going to go ahead and use this formula right here, 5/9 F minus 32. And let's call that Fahrenheit 1. And then you have a second Celsius temperature. And you do this the same way. And if we subtract, and let's see what happens. So we get C1 minus C2 is equal to 5/9 minus 5/9. And I think you see what's going to happen here. Because if we do a little algebra, and I'm doing way more steps than I really should. Minus 5/9, 32. Minus 5/9, it's Fahrenheit 2. Minus a minus is a plus. What we see very easily is that this negative cancels with that. And we get the following result. See, the difference in centigrade, the change in, is going to be 5/9 times the difference in Fahrenheit. Or if we let delta C equal C1 minus C2 and delta F equal F1 minus F2, we get delta C is equal to 5/9 change in Fahrenheit, or doing a little bit more algebra, 9/5 change in centigrade is change in. All right, so that's what it is. So a half a degree. So here, your change in centigrade is 0.5, which is 1/2. So 9/5 times 1/2 is 9/10, which is your change in Fahrenheit. Okay, and that's again, I've actually seen this in, it's horrifying to say, but I've actually seen that in science books, textbooks for K through 12. Fortunately, I've never seen a college textbook make this error, and I hope I never do. So that's a temperature conversion. You do have to worry about that. But what's this have to do with the concept of differentials? Well, let's go back to our original thing. If we have C, a function of Fahrenheit, so it's going to be 5/9 F minus 32. Now let's differentiate, take dC, dF. Now all calculus students know, I'm just not going to multiply these two together. All calculus students say the derivative of C with respect to F is just 5/9, right? Well, in the concept, using the concept of differential, and I know this is not a fraction, but using differentials, we get DC is 5/9 DF, or if we use linearization notation, and that goes through very automatically. And the idea here is when you're dealing with change, this is what you're talking about right here. In other words, what this says is a 1 degree change in Fahrenheit is 5/9 times that degree change in Celsius, and just vice versa. So, and if the author had, either had calculus and remembered any of it, they'd recognize that this function here has a constant derivative of 5/9. So that's how you relate the changes, a change of a degree Celsius to a change in degree Fahrenheit, and vice versa, via this little relation right here. So I guess the moral is, unless you're going to, let's say, teach math or be in something where you have to differentiate often, you may years from now forget how to integrate inverse tangent over 1 plus x squared dx, or something like that. But if you remember the concept of differential and how these relate change to change, then you will not be making an error like this. Okay, so thanks for watching.